Alright. So who do you wanna go first to it? I guess, do you wanna just do? Okay.
So for question number 8, my only problem with that, I didn't understand how to set it up because
Okay.
I read the article
Uh-huh.
and it was the one with the Barry Bonds and who'd come next.
Oh,
and
okay.
pitching.
Uh-huh.
I was so confused on who's
Okay.
who's the first player and what the options are.
Did you guys do that one? Did you look at that yet? No, then? Okay, so the deal is, if you look at the, let's look at the clip. Just gotta make sure I remember this right. Not just about bonds, but who's on deck.
Right.
Okay, so big thing is, so this is a baseball thing, so Bonds is a great hitter, right? So the question is, you can either pitch to him or not, right? If you pitch to him, then he might
Hit a home run.
he might hit a home run. Okay, so the idea is that you might walk him, right? It says, okay, so you walked him last year. However, what?
If he has a good batter behind
If he has a good batter behind him, then you'd
pitch.
rather pitch to him,
Yeah.
right?
But the
Does that make sense? Right, go ahead.
The thing is, I wouldn't know how to who would be the first player, who would be the second player.
Okay, that's a good question. What do you think is the relevant? Who's making the first decision?
First decision would be the pitcher,
What? The pitcher's doing what?
whether he should pitch to Barry Bonds or not.
Okay, so then what would the second person be?
The second person would be the Giants,
Uh-huh.
and deciding who would be batting behind Barry Bonds.
No, okay, so does the pitcher first decide what to do, and then the Giants decide who to put behind
The
Bonds?
Giants decide who to put
Exactly
behind
right,
Bonds. Okay.
So sometimes people who they're not familiar with baseball really get upset with this kind of thing. It's like, how do we know this? But yeah, so first the Giants make a decision who to put behind Bonds,
Okay.
right? So I think in the case, so the first one is Giants, right? So it's Giants, and so the Giants I think it was either Alfonso or Cruz, right?
Yeah. Was it Alfonso? I'm good, yeah, it was Alfonso.
I think that's right. Yeah.
Yeah, I think so.
Alfonso was the one who's not so good, right?
Right.
And then or you could put Cruz as doing better, right?
Yeah.
Okay. First the Giants do that. Okay. And then
Oh, and the pitcher can decide whether to
right,
pitch
and then
or
the
not.
pitcher decides for the pitcher not right. So the pitcher can either
Pitch
pitch or
walk.
walk, yeah. So this is not pitching to Alfonso, it's pitching to Bonds, right?
Right.
Or walk, right? So maybe here the pitcher can either pitch
Okay, that's
Or
where I was
walk.
confused.
so either pitch to Bonds or walk to Bonds. Okay, so then it's just a matter of running to the payoffs and
And that's our choice.
yeah, I think it's more or less just, but I think it's pretty clear, right?
Yeah, that was only problem we had, just setting up the game.
Okay, yeah. I think, for example, what would be the best thing for the Giants?
The best thing for the Giants was for them to put Cruz
Uh-huh.
and him to pitch to Cruz. Or pitch to
And pitch to Bonds?
Yeah. Or walk Bonds. But
Yeah,
then
I think
Cruz
that's
would
right,
hit a home
exactly
run.
right, yeah, something like that, yeah.
Okay.
Yeah.
So the best option would be the last one.
Yeah, I think I'm thinking that.
And that would be the worst for the
That would be the
pitcher.
worst for the Giants, yeah. No, hold on.
For the pitcher. Wouldn't it be?
Yeah, right, exactly. That would be the worst for the pitcher. Yeah, the best for the Giants would be to put in Cruz and have
And then have Bonds go up.
Bonds. Yeah, yeah.
Okay.
I think that's right. Okay,
So
I think that's right. Yeah.
we
So do you want to?
can-
You can put yours up.
Okay.
Do you want to do the whole problem, or do you want to just? You think you're okay?
Let's do the whole problem. just to
Okay,
make
let's
sure.
see if it works.
Okay. So in a situation with Giants, with
Mhm.
Cruz walking,
You can pull up and see if you want.
I give the Giants a payoff of, say, 20.
Okay.
The pitcher a payoff of -20.
All right.
And then Cruz and then pitching to Bonds is good for the Giants still,
Mhm.
but not as good as not.
Mhm.
And I guess it'd be like -10
Okay.
for pitcher because at least it's not 2 home runs.
Okay.
And then Alfonso, walking Bonds with Alfonso, that's the best situation. That's the worst situation for the Giants.
Okay.
And that would be the best situation
Mhm.
for the pitcher.
Okay.
And pitching the Bonds with Alfonso on deck, that would be the same as this one, right?
Let's see. Okay. Just let it turn and see. Okay. So let's see. So okay. So let me think. I think the idea is that right, the Giants want to influence whether the pitcher will pitch to Bonds or not, right?
Yeah.
And the idea is that the Giants put Cruz in.
Oh, okay.
I think
So this would be better for the. This would be better for the pitcher and worse for the Giants because then they.
No, I think this is okay.
Oh, it's okay.
The idea is the Giants put Alfonso in, and the pitcher will walk Alfonso. Sorry, but pitcher will walk Bonds.
You know, we put bees there, so that makes
Right.
sense.
Yeah.
Pitch,
Yeah.
walk.
Yeah. So like because 20 is bigger than -10, right?
Yes.
Given that Alfonso's a weak hitter, we don't mind walking Bonds because we don't think that Alfonso's going to put him in, right? However, if Cruz is behind, then the pitcher is going to want to pitch to Bonds, right?
Right.
So if we do our sub-game perfect thing, so for example, at this point, what is
You
If-
know, walk.
right,
Bonds.
right? How about here? So if the Giants put in Cruz, and what is the pitcher?
Pitch to Bonds.
Right. So then, given this, what are the Giants going to do? Giants can either go Cruz and get 10, or Alfonso and get -20. So what is the Giants?
Cruz.
Yeah.
Okay.
That's
it.
Yeah, that sort of makes sense, right? The
Yeah.
idea here is that who the Giants put in affects whether the pitchers will pitch to Bonds or not, right? So
Yeah.
that's why the Giants want to put in Cruz. They want to put a good hitter in
Okay.
after Bonds to make the pitcher pitch to Bonds.
Right.
Right, that's the idea. That's the idea.
Okay.
That's it.
Okay.
Yeah.
And also another quick question.
Uh-huh.
There's a situation here. This one. Yeah. Like this is what I was talking about, like where
Mhm.
you have to write down all of these.
Right.
So
yeah.
is it okay if I just put the arrows in for that?
Yeah, sure. So like I think in my answer key I'll have like there's some cases there's a tie, right? I think it's
Okay.
here, right? For
Oh, this one. It's
Oh, yeah.
me taking 2 or taking.
Oh yeah. So kind of like I said in class, to find just one sub-game perfect Nash club, you can just write down one. You don't write them both, right?
Right. If you want to find all.
And you
subgame.
write them, fund them all, and you have to write them all sort of in separate trees.
So I have to do this like this one is one tree and then this one
Yeah,
is another tree.
right. But if to simplify, you say, well, this person B has a tie here, and it doesn't matter what.
So if I just write down, here, for example, A has a
Yeah,
tie.
that's
So if I
fine.
just write that down on the bottom and say B
Yeah,
has a
that's
tie
fine.
at
Sure,
this node,
that'll be okay.
that'll be okay.
Yeah, sure.
Okay.
Yeah.
I think that's it.
Yeah. Oops. I didn't get to see that.
Spare all the viewers.
For all the viewers out there. Yeah. So the question is, so here B is can either take one or take two, right? He loses either way, exactly.
Yeah.
And similarly, I think
A can take one or take
yeah, take one or take two, it's tied either way. So there's 2 points, which is the tie.
Right.
So there are 4 sub-game perfect Nash club. If we were to write them all down, you'd have to write them all 4 separate trees and write them all.
Exactly.
But if you want to just save time, you can just put a little like note saying, hey, here B has a tie. It doesn't matter what he does. Here A has a tie. Blah blah blah.
Okay.
Yeah. That's fine.
And one last thing.
Uh-huh, sure.
Sorry guys.
Hmm.
For what fire is this? With the one with the matching sticks,
Uh-huh.
I came up with a theorem. I don't know if this is the same theorem that you had,
Uh-huh.
but which one is matching sticks? Well, anyways, it's just like
Is the one the crossout game?
Yeah, the
Yeah,
crossout
yeah.
The theorem that I came up with last night was that if you start off in the middle and you mirror exactly what player 2 does,
That's right.
you're gonna win no matter what.
Right, exactly. That's true.
Okay.
It makes sense, right?
Yeah, it does
Okay,
because
yeah.
I tried it with like so many numbers and I could just look at it. And
Right.
Okay.
Okay.
Thank you so much.
Sure. Sorry, what's your name? Sorry?
Nathan.
Nathan,
No,
okay.
I
didn't get to too long.
What year are you in?
It's fine.
I'm 30.
Oh, cool.
That's my last class.
Alright.
Oh, no, I saw you offering
Uh-huh.
class next.
Yeah. It'll be kind of the continuation.
Of
Yeah.
class I
Yeah.
Okay, that's great.
Okay.
We can do that.
Oh, fantastic.
Yeah.
Good, okay.
See you soon.
Okay.
Okay.
Alright, see.
Yeah.
He's in because I want to see his questions.
See ya. You wanna sit here? You can.
Probability and mixed strategy.
Okay.
I have the notes for it, but when I was going back, I just couldn't understand what I wrote down even.
Yeah, sure, no problem.
I just don't know how to do any of it.
Okay. Good for the viewers. Oops. Let's see, you wanna just go with your notes what you had before, let's see.
Oh, the original one?
Yeah. something like this. So the basic idea of probability, so you get the idea of like, so let's just do this one here. Okay. So this is our matching pennies game or whatever, the Calais, what's the other one? The D-Day one, right? So if I go L and you go L, I get 1, right? And if I go L and you go R, I get 0, etc. So this is where, in this game, I want to do the same thing as you, but you want to do something different, right? It's like the D-Day example. Okay, so are there pure Nash equilibria in this game? So for example, if 2 does L, what does 1 want to do?
L.
Right, so I put a little star there. If 2 does R, what does 1 want to do?
R.
If 1 does L, 2 wants to do what?
R.
So put the plus there. Maybe I should do that. Do you mind if I mark all over your stuff?
Oh yeah, it's fine.
If 1 does R, 2 does wants to do what?
Yeah, R.
If 1 does R, 2 wants to do
L.
L, right? So there's nothing above the star and plus. So there's no pure Nash equilibrium. So therefore you're thinking, well, maybe we'll do a mixed thing where people are randomizing, like just like in the penalty kick, right? People are randomizing. So how do I figure that out? Well, I say that person 1 plays L with probability P. That's what that P is there. So 1 plays this with probability P, plays L with probability P. So I put in little braces to say that's what that means. 1 plays R with probably 1 minus P. Okay? I just set that up. 2 plays L with probability Q. And 2 plays R with probably 1 minus Q. Okay, I assume that. So I'm going to make this a Nash equilibrium. How will this be a Nash equilibrium? One in which people are mixing. Okay, so the way to think about it is this. If 1 plays L, what's 1's expected utility? So I'm going to write that down as EU, person 1's expected utility from playing L. Okay, what's that going to be?
Either 1 or 0.
Yeah, so he's going to get either this 1 or this 0, right? He gets this 1 with probability what?
50% chance.
Well, given that we have, say, person 2 plays L with probability Q, plays R with 1 minus Q, right? So if he plays L, he's getting 1 with probability Q, and 0 with probability
1
minus Q. So it's going to be 1 with probability Q,
Oh, I see that. It's on a little corner.
and 0 with probably 1 minus Q. So this is the expected utility, right? Because expected utility means the payoff from something times the probability of that something, right? Added up over all possible things. Does that make sense? So he's getting 1 with probability Q, so that's 1 times Q. He's getting 0 with probably 1 minus Q, so we have this. Okay, so if I do this math-wise, this becomes 0, and this is just what?
1Q.
Yeah, I'll just make it. Okay.
But what is Q?
Oh, Q is 2. We wrote down, this is 2's probability of playing L.
Does it come out to a number of it? Or just
Yeah, we will. Yeah.
Oh, okay.
And so that's what we're going to do. Okay, so this Q is the probability 2 will play L. Okay. Now, similarly, what is person 1's expected utility from playing R? If he plays R, okay, what's he going to get? Well, he's going to get 0 with probability Q. Yeah. And then he gets 1 with probability what?
1 minus Q.
Yeah. So this becomes, if I just do this up, this becomes what? 1 minus Q. Okay, so the idea here is that in a mixed Nash equilibrium, if I'm randomizing between these two things, I've got to have the same payoff between playing L or R. Okay? So if I use the notation, this should be like a little script L. So a little R like that. Okay, sorry. So in a mixed Nash equilibrium, these things have to be the same. If this number is larger than this number, then I'm not going to randomize between L and R, right? If this number is bigger, I'm just going to play L all the time. If this number is bigger, I'm going to play R all the time. For me to randomize, these numbers have to be equal.
Okay.
So I set Q equals 1 minus Q. And I solve for Q and get what? 2Q equals 1. Q equals 1. Yeah. See? Make sense? I'm just doing algebra and I set Q equals 1 minus Q.
Why'd you jump to Q equals 1 minus Q?
How did I get that? So I'm saying that Q is my expected utility from playing L.
Mhm.
Right? 1 minus Q is my expected utility from playing R. I set them equal to each other because I said that if I'm randomizing between L and R, my payoff from playing L and the payoff from R have to be
okay.
the same. That's it. So I set Q equals 1 minus Q. And then I just do the math. And Q equals 1. Clear?
Yeah.
Okay. Now, let's do the same thing for, so this is the so-called switchover probability for person 2, right? So-called switchover probability. Now, this is what you did for person 2, right? Let's do the same thing for person 2. Person 2 can either do L or R. If person 2 does L, then she's getting the 0 or the 1. Right? She gets the 0 with probability P, that's this. And she gets the 1 with probability 1 minus P. And that ends up being this 1 minus P.
Okay.
If she plays R, she's finding the expected utility from playing R. It's 1 times P plus 0 times 1 minus P is equal to P. So this is the expected utility for playing L, this 1 minus P. This is the expected utility from playing R, it's P. So I set them equal to each other, that's this thing here. Okay, I get this, and I get P equals L.
Okay.
So this is the sort of switch over. So if I were to write down the mixed Nash equilibrium, this paper is like from last year or something. So the mixed Nash equilibrium is going to be, it's good to write it out in words, because that way it's clear kind of what it is. Mixed Nash equilibrium is this. 1 plays L with probability what? It plays L with probability P, and be solved for P, which is what? Plays R with probability 1 minus P. Since P is a half, what's 1 minus P?
Half.
Right. That's a 1 does. 2 plays L with probability. She plays L with probability Q, and Q is what? Right? Plays R with probability what? Half, right? That's the mixed Nash equilibrium. That's it. So 1's doing a 50-50 mix. 2 is also doing a 50-50 mix between
So this is the answer for the.
that's the answer.
So is the mixed Nash equilibrium the same thing as that one chart we did where you put like the pluses?
Yeah,
and
exactly
the
right. Right,
triangle,
right.
like-
Exactly right. So this is the fast way of doing it without doing all the whole box stuff.
So
But
we don't
just
need to
give
do
it-
the.
No, you don't have to.
Oh, okay.
But the reason I did the box is just to show that the mixed Nash equilibrium is just like any Nash equilibrium. It's just in the game where
Oh, okay. So we
people
never
have
need to
some
do
structure.
that.
You never need to, yeah.
Oh, because I was trying to. I got lost doing that. I didn't know.
Right. We can do that
Okay.
too if you want to go through it. But that's just mainly to motivate. Why
Okay, no, I
mixed
think
Nash
this is
equilibrium
easier
is-
for me.
Yeah.
Okay.
Yeah.
Alright.
Anyway, so again, if you did have a different game like here, oh, I see you were trying to do them.
Yeah.
Yeah, then you would just do the same thing, it's just be different numbers.
Okay.
Yeah.
Sounds good.
Yeah.
Thank you.
Yeah, that's it.
Yeah.
Anyway, that's all right.
Are these gonna be up?
Uh-huh.
These videos?
Yes, yeah. I guess I try to do maybe, it takes a while to compress them, maybe today or something.
Okay. Cool.
Yeah,
Thank you.
sure.
I don't have the question.
Oh,
but
okay,
it's
this is
the
the,
boyfriend girlfriend.
oh, right, okay, cool.
Yeah. I just like
Sorry, what's your name again, sorry?
Allie,
Allie, and what year are you in?
third year,
Okay,
just
cool.
transferred.
Oh, great, where did you transfer from?
Moore Park.
Oh, wow,
You know what that is?
kind of, yeah.
Yeah. Like Thousand Oaks area.
Yeah, exactly.
Yeah.
My son had a marching band competition up there.
Oh, okay.
Yeah. It's nice there. It's kind of hot in the summer, isn't it?
Yeah. It's
Yeah.
pretty warm.
How do you like UCLA so far?
I love it
Oh, that's great.
so much. It's way better.
That's great.
Yeah.
That's very good. Okay.
Thank
Alright,
you.
see you later. Where are you from?
I'm from Stockton.
Oh, really?
Yeah.
What's your name again, sorry?
Tiffany.
Tiffany. And what year are you in?
I'm a first year.
Oh, great. How do you like it so far here?
I love it.
That's good.
Yeah.
People seem to like UCLA, which is a good thing.
Yeah.
Stockton's not so bad. How do you like Stockton?
I don't like Stockton that much.
There's like University of the Pacific there or something?
Yeah.
Is that a good place?
Yeah, it's pretty.
Really?
It's nice. Yeah, I got accepted there. If
Yeah.
I go
Yeah,
there.
yeah, okay.
Um,
So, but you're getting along okay in terms
Yeah.
of freshmen and all that?
yeah, that's fine.
That's
I
good.
haven't gained any weight.
That's funny. Okay.
Yeah, I just like, I think I kind of got the setup, but I
Okay,
don't know why
sure.
the number is like,
Okay.
I know
let's-
it's not right.
Let's look at the thing. Works out. 4, right?
Mhm.
This is problem number.
6.
7-day cruise. Okay. Each person joins the other company and gets a payout for 5 of every day the relationship continues. However, no person wants to be dumped. If a person breaks up the relationship, the other person, the dumped one, gets -10 and a pay. Okay, so Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay, so you get 5 for every day you make two together, right? So this is like the end. It's like 7 days, right?
Mhm.
So it's like everyone gets 35 except the girl gets dumped, right? She gets the 25, right?
Yeah.
Minus 10. Okay, cool. How about here? What goes in here?
So the girlfriend.
Oh, by the way, at this time there's no this doesn't happen, right?
Yeah,
You can't. So
yeah.
there's it's over at that point, right?
Yeah.
Okay, so the girlfriend can either stay or break up. So this time,
The girlfriend's breaking up,
yeah. So
so she gets the better payoff.
right.
Which is
So they spent how many days together? 6, right? So it's 6 times
Yeah.
5, which is 30, right?
yeah,
So her payoff is going to be
30.
30, right? I think so. Okay, and then
He's gonna get 20.
right. Okay, how about here?
It's 4. So
Oh, 5, right?
or 5.
Yeah.
Oh yeah, 5.
Mhm.
So it's gonna be 25 for the boyfriend,
And
and
then,
then 15.
yeah, I think that's right.
Okay. And then
And this is going to
40
be
is, so the girlfriend. Oh wait, the
Yeah.
boyfriend gets 20, and then the girlfriend gets 10.
down here.
Yeah.
Oh, this is where the girlfriend dumps, right?
Oh, the girlfriend.
Yeah,
So the girlfriend gets 20,
right.
and then he gets 10.
That's right. Yeah. Does that make sense?
Yeah.
See, there's kind of a pattern, right? So
Yeah.
this is like
That's
35,
what I was
35.
like, I
Yeah.
don't know.
This is like 35, 35, but then you take away the 10 for being dumped, right? This is like 30, 30, but you take away the 10 here. This is like 25, 25, but you take away the 10 here. It's like 20, 20, but you take the 10 here. See that right here? This would be,
30, so 15,
right.
and
Mm,
then 5.
and here is,
Is 2, so 10, and 1, or 0.
I think, but here the girlfriend dumps, right? So
yeah,
here the
so
boyfriend
0,
gets 0,
and
10. Okay, and this is,
So 1 day, right?
yeah.
Okay, so
I think,
5, and then negative.
yeah, 5 negative. Right?
Yeah,
This is 10, 10? No, this is 10,
0.
10, 0. Yeah, I'm sorry,
0,
not 0.
10,
Oh, yeah, I'm sorry, 0,
0,
10,
10,
yeah,
yeah.
thank you. 0, 10.
And how do we find
Okay, let's see. Represent the sentence is an extensive form game. That's what we did. And there's again perfect natural form. So let's do that. Let's do the backward induction part.
Okay.
So how do you do that? You start at the end,
Mhm.
and then so what would the so here boyfriend's choosing, right?
Mhm.
And there's only one choice, right?
Yeah.
So
So
break up. What does the girlfriend do here?
breaks up.
Right, 'cause so the girlfriend goes on, stays, she'll end up getting what?
25,
Right, but if she breaks up, she'll get what?
30.
Right, so she'll get 30.
Okay.
What does the boyfriend do here?
He breaks up.
If he stays on, he'll get what?
20,
If he breaks up, he'll get.
25.
Right. Okay, what does the girlfriend do here?
The
If
girlfriend would break up.
right, if she stays,
20,
she'll get 15. If she breaks up, she'll get
20.
20. So okay, how about here? Boyfriend, if he stays, he'll get 10. If he breaks up, he'll get.
15.
So he's going to.
Break up.
How about here?
The girlfriend will. She will break up.
Yeah, because
10 is greater than 5.
yeah, exactly. And finally,
The boyfriend will break up because
mhm,
5 is greater than 5.
yeah. Yeah, yeah.
So we can say that they're just gonna. Will we just say that they're gonna break up on the first day?
Yeah.
Because no matter what, like
Right,
they're
right,
gonna
right.
break up.
Yeah, that's the idea.
Okay.
That's
okay.
it. So that, I mean, the what's interesting about this game though is what is that look, they break up even though these payoffs are much higher, right? They would both want to push it into, push the breakup as far as possible to the end, right? Because they both enjoy each other's company, right?
Yeah.
Both would rather do, for example, break up for the end as over the breaking up in the beginning, right? But they can't get it to happen. Why?
Because their payoffs are great. Like they're what's it called when you
Uh-huh.
choose
The background induction.
Yeah. Like I don't know.
Well, think about it like so. They would both be better off if they go they stay together all the way to the end, right? But at the end, the boyfriend has to break up, right?
Uh-huh.
So, one day before the breakup, before the end, what does the girlfriend think? She thinks, well, I could break up with him, or I could stay with him. If I stay with him, what's going to happen? Well,
Like, 'cause they both know they're gonna break up.
yeah, exactly.
So
So the
they'd
girlfriend-
rather not be dumped.
Yeah, exactly, right.
So,
Yeah, yeah. So, the girlfriend says, well, you know, I'd rather dump him first, and so therefore I'll break it early. But then the boyfriend then on Friday says, well, I know she's going to, you know, break up with me tomorrow, therefore I better break up with her now, and etc. It kind of rolls all the way back, and so they a much worse payoff than they end up getting down here, even though they
Yeah.
could have gotten something better.
Okay, so that would be the like sub-perfect.
So yeah, this is the outcome. This is what they actually end up reaching, but the subgame perfect Nash equilibrium is the specification of all these arrows. So to write down this, for example, so if I write down this, okay, this would not be correct.
Okay.
This is simply the outcome they reach.
Okay.
Okay, what the subgame perfect Nash equilibrium is coloring the arrows for all this whole thing.
Okay.
So if I write down this whole thing as a subgame perfect Nash equilibrium, that's correct.
Okay.
Because it's specifying what everyone does at every node.
Okay. So like if I put like a boyfriend breaks up
Mm-hmm.
and like every time.
Oh yeah, if you write it in words, you would something like boyfriend breaks. It'd be like B or whatever. Oh, but if you don't, you know, you don't have to write it down in words because the tree alone tells you what everyone's doing at every node.
Okay.
Right.
So for like whenever I
Mhm.
do the problem, like all I'd have to do is like this and then this little.
Right.
Okay.
As long as from every node something is colored in.
Okay.
Okay, so for example, say I have a game like this, something like that, and I just color in this. Okay, this will not be sufficient because in a Nash equilibrium you have to specify different strategies, right?
Mhm.
And a strategy has to specify what people do at every single node. This is not sufficient because we'd have to specify also what happens here.
Okay.
You see, so
Yeah.
but once you write down, you make a choice for every single node. If you color in something, then you're okay. So this would be sufficient.
Okay.
Example.
I get it. Thank you.
No, yeah, no problem.